So, just a quick video, first of a series of them, where we're going to look through the example document of a lab diary about an experiment to do with pendulums. So, this is just the instruction sheet. There's not very much to it. You're not given much more information than this, but it just gives you the aim of the experiment, which is to find g, in other words, acceleration due to free fall, by using a pendulum, and it gives you the equation. This is what a lot of very simple lab sheets will look like. You'll just get a bit of information, a bit of an aim, and an equation. So one of the things you can do is go away and look into interpreting graphs and look at some graph skills, specifically stuff to do with equation of a straight line, to figure out how you're actually going to do this experiment. So one of the things to do with this is to square both sides. So that gives us t squared equals 4 pi squared L over g, get rid of the square root. And then you can see that t squared is proportional to L. So if we were to plot a value of t squared against L, it should give us a straight line. And if you understand the equation of a straight line, y equals mx plus c, you'll be able to see that the gradient of that would be 2 pi over g. So if we can plot t squared against L, or time period squared against length of pendulum, we'll get a gradient of 2 pi over g. Equally, you might have an argument for doing it the other way around, in which case the gradient will be flipped and it'll be g over 2 pi. Either way, you can use the graph to calculate a value for g. So you can do this experiment yourself. You can actually set it up, or there is actually some backup videos that you can do if you just want to watch somebody else do a pendulum. But you can do this experiment yourself quite easily, just with a couple of bits of blue tack, sellotape or blue tack the string to a edge of a table. I'd suggest a corner, and time it swinging backwards and forwards. That's the experiment in a nutshell. But we're going to look in a few different videos at the different sections of the lab diary. So to start with, we're just going to have a look at the beginning, because that's where obviously you're going to start with your own lab diary. So here it is. This is a document that you've got access to in multiple bits, but they're all just PDFs. Now, just to explain the document a little bit, the stuff in black is the lab diary, so that's the bit that's effectively been written in the book. All the stuff in red is just annotations, just little notes. You wouldn't do this. These are just mine. All right, so to explain things to you as you read through it, think of them as a little bit of a commentary on what's going on. So in the video, I'm just going to look through each bit and point out some of the key parts. But it's more important you spend time with the document and give it a careful read through. And between this and the guidance documents, get a feel for what each part of the lab diary needs to be. So to begin with, we just want an aim. It doesn't have to be anything complicated, but I want to know what you are trying to find and how you are trying to find it. It's not an abstract, it's not a full abstract. But for in this example, we want to find g, acceleration due to free fall, by recording the time periods and lengths of a simple pendulum. So it gives me an idea of the method. There are lots of different ways of finding g. I need to know which one this experiment is meant to be. Okay, then on to the procedure. You'll notice I've got a really, really simple diagram. It doesn't have to be anything complicated. It certainly shouldn't be arty in any way, shape or form. Simple, 2D, labelled, and you can even put quantities on it. So like length, for example, is clearly indicated. I've been able to show that it goes to the centre of the pendulum bob from the bottom of the clamps at the top, which are the bits marked by an X. That's the sort of fairly acceptable symbol for a clamp. So now when I refer to L in the procedure, it's really clear what I'm talking about. Notice the procedure isn't bullet pointed. It's written in past tense, in passive tense, and third person. So it's this was set up. You don't need to explain to me how equipment got set up. All I want to know is, how do I set it up? Give me a diagram, I can figure it out for myself. However, if there are really important aspects of the way that something is set up, or the way that it's measured, that make that measurement more accurate, for example, removing or reducing the effect of parallax error, i.e. getting your eye down to the right level to read off a thermometer, for instance, that can be mentioned in the procedure, because it's not just a case of telling me how to read a thermometer, it's telling me how to take a temperature accurately. What I'm looking for in here then is I want to know what your variables are. So we've already decided in the previous part that we need to plot t squared against L. I don't mention that in the procedure anywhere. The procedure doesn't care about the analysis. Procedure is about what data do I need to collect, how do I do it? Well, if I want to plot t squared against L, for the procedure I need to say how I'm going to collect data on t, the time period, and the length L. I need to then build on that and say, right, what am I going to change? I'm going to change the length. I'm going to therefore measure the period as a result of it. So I identified my dependent and independent variables. Also, at this point, I'd be mentioning anything I try and keep the same. So, for example, if I was measuring the mass of the pendulum bob or something like that. Now, in this case, I'm actually not going to. I'm just going to use the same pendulum bob every time. And I know it doesn't really matter. There isn't anything else to measure in this experiment. I also offer, for example, a range of different lengths. Now, I might change that. Now, if I do change anything, just cross it out but leave it readable. Lots of people don't like this because it's messy. With them now, tear this page out and go and rewrite it. Waste of time, a cause of stress, and it will lose you your job. Get used to crossing things out. All right. This could be a result of I tried the experiment and actually 10 to 40 centimeters. It swung really quickly. Getting up to 60 centimeters, it gave me slightly better time periods. It swung a little bit more slowly and over a longer period of time, and it just worked a bit better. And the clamp was maybe taller than I predicted. So I've changed my procedure a little bit. I've updated it. Absolutely fine. And in this instance, we're recording 20 oscillations because recording one is just too fast. So it's all the little details. What exactly do you need to be able to tell somebody so that somebody else could read this and collect the data you want them to collect? You could give this to somebody who doesn't know what your experiment is, and they will give you the data you need, because that could be what will happen. Your procedure could be given to somebody else and they will collect it. And if you don't say, change the length, and you wanted them to change the length, funnily enough, they won't do it. So you need to make sure you're thinking about your procedure from that point of view. Could somebody else follow it? Avoid any sort of flowery language. Just keep it short, straightforward, to the point, continuous prose. If things end up being a bit out of order, so if you suddenly realise there was something you mentioned at the beginning and actually I need to elaborate on that a little bit and I end up writing it down here, yeah, it doesn't matter. This is not your formal report. It's a working document. You'll sort all that stuff out when you write a lab report, if that's what you're going to do with this. So don't worry about it for now. If you did do any preliminary investigations or readings, you could include those here. And then any conclusions you drew from that or decisions you made about the method, you could also make a note of.